Let x equal to this column vector which is belonging to R cube be a non-zero vector, and let A equal to x transpose divided by x transpose x, then the dimension of the vector space this over R is. First, you may get confused as matrix A is defined as x transpose upon x transpose x, because division in matrix division in matrix is not defined. Then what is this? If x is this column vector x1 x2 x3, then its transpose will be x1 x2 x3. Now take product of these two matrices, because this is 3 by 1 and this is 1 by 3. So product, these two matrices are compatible for product, and resultant will be 3 by 3 matrix. So after multiplying this means x transpose, we will get x1 square first row with first column, x1 x2 x1 x3 x1 x2. Now this is x2, so x2 x1, it is perfect x1 x2 x2 square, and this will be x2 x3 x1 x3 x2 x3 and x3 square. In diagonal entries you can check, this is x1 square x2 square and x3 square. Now this is x transpose, as these x1 x2 and x3 are coming from real set, so x transpose x, what is it? It is x1 x2 x3 and x is x1 x2 x3. So resultant will be x1 square plus x2 square plus x3 square. This is matrix and this is 1 by 1 matrix. So this is a number, this is a real number. We can, if I write 0 in this matrix, 0 in this format, then its simple meaning is 0. 0 is a real number, so this is a real number. So you can divide matrix by this real number, means all elements divided by this real number. So now matrix A is suitable as given, and we have to find dimension of this set. Suppose this set is S, I call, or W you can say. Y belongs to R cube such that AY equal to 0, means all those solution, if we find matrix representation of AY equal to 0, then we have always solution. I mean consistent, this system is consistent and have solution. So this is null space, this is nothing null space. So we have to find dimension of null space, means nullity. As this is a single constraint, so dimension will be, because this is from R3, so 3 variable used, 3 minus number of constraint is 1, so 2 is the dimension of null space, or 2 is nullity. You can find directly, or as we have to find dimension of this is second method. You can understand AY equal to 0, and matrix A is x1 square, x1 x2, x1 x3, x2 x1, x2 x2 square, x2 x3, x3 x1, x3 x2, and x3 square. This is, and we should to divide by this number, as number was x1 square plus x2 square plus x3 square. So we have to find dimension of ay equal to 0, because this is the number. So we have to find dimension of only this matrix, because dimension doesn't alter when we multiply or divide by a specific number, dimension of null space. So find dimension of this matrix. Dimension of ay equal to 0 means only find dimension of, so suppose call this is a x, so ay equal to 0. Now we have to find dimension of this set, another set, you can say s. So dimension of this one you can find by reducing it in reduced echelon form. Now row reduced in echelon form, we need to apply some elementary row operation, because you have to make 0 under first position to make this is 0 and this is 0. So r2 by r2 minus x2 upon x1, this is a number with r1. Now apply this, and second r3, how r3 you need to change, r3 minus x3 divided by x1 r1. So you need to apply this to a elementary row operation, and you will get x1 square, x1 x2, x1 x3, 0 0 0 0 0 0. So now you can check that you have two free variables here, because this is pivot position, this is basic variable. So one is basic variable and two are free variables. So dimension of ay equal to 0, dimension of this set is 2. So 2 is correct answer of this problem.